Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solid. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have the isometric 3D projections of a solid available with us, and we are required to convert this 3D isometric projection into the orthographic views, that is front view, top view and the left hand side view of the solid we need to obtain. And we need to also check that this is going to be the direction through which the front view of the solid will be obtained. Through this direction the left hand side view will be obtained, and through this top view when the solid is observed from above. Now in order to draw the orthographic projection, that is the front view, top view and the left hand side views, first of all we need to obtain the dimensions of the front view, top view and the side view in the orthographic projection. So now we can check from this isometric projection that the width of the solid happens to be 75 millimeter and the height of the solid is 40 millimeter. So the front view dimensions will be 75 millimeter by 40 millimeter, right? So this is the front view or the front face which we are going to obtain in the orthographic projection. So its dimensions will be 75 by 40 millimeter. 75 is the width and 40 millimeter is the height of the solid. Then from the top view we need to obtain the size of this orthographic projection. So in the top view we are going to see the width of the solid, which is equal to 75 millimeter, and the depth of the solid will also be visible to us in the top view. So this dimension of the top view face will be 75 millimeter by 45 millimeter. So this is the size of the top face of the solid. Then regarding the side face of the solid, the dimensions of the side view should be, in the side view we are going to witness the depth of the solid, which is equal to 45 millimeter, and the height of the solid, which is equal to 40 millimeter. So the side view face of the solid should measure 45 millimeter and 40 millimeter in the orthographic projections. And next let us see what are the faces of the solid which will be visible to us as we are going to look at the solid from the front side, from the top side and from the left hand side over here. So these are the different faces which will be visible with us, and for the purpose of convenience we have marked the color coding also. Surfaces A and B will be visible while we are looking at the solid from the front side, right? So these are these two surfaces A and B. They are marked with pink color. Then this is another, you see, left hand side view. So there are going to be surface 1, surface 2, surface 3 and surface 4. So these four surfaces will be visible to us as we are looking at the solid from the left hand side. Then when we are looking at the solid from above, so in the top view the surfaces which will be available, they have been marked as X, Y and Z. So these are the three surfaces which will be visible to us. So let us start discussion about surfaces A and B. So please check, as we are going to look at the solid from the front side, this is going to be my first surface. Surface A, it is an angular surface which is having a lower block, you can say. This is the lower element and this is the upper element of this particular surface over here. Now once we combine the lower element with the upper element, we are going to get the integration of both of these elements into the surface A. So surface A, since it is parallel to the vertical plane, the true shape of the surface A will be visible to us in the view, that is front view, right? Then you have second surface, surface B. So this is the surface B which is corresponding to the vertical surface corresponding to web number 2. This is going to be my web number 1. This is going to be my web number 2. So corresponding to the slant portion, you can see in between I have got a slant portion also. So this is the intersection of the slant portion and the vertical internal portion of this web. This is called surface B. So while we are going to obtain the projections onto the vertical plane in the front view, surface B, it will be overshadowed and overlapped by surface A, right? But because of this intersection of this slant surface and this is the vertical surface of internal vertical surface of this web, there is going to be a dotted line corresponding to this surface, you see intersection over here. So that is why we have marked separate surfaces for surface A and surface B over here. Now when we are going to look at the solid from the left hand side, this is the first surface which will be visible to us. This is surface number 1. So this is the vertical portion of the lower block. You see, this is the lower block and this is the vertical portion of the lower block which will be visible to us from the left hand side. Then these are the two vertical surfaces. This is vertical surface corresponding to web number 1. This is vertical surface corresponding to web number 2. So corresponding to these two webs over there, the surface 2 and surface 4. So surface 1, surface 2 and surface 4, they will be viewed as true shapes onto the profile plane while we are going to draw the left hand side view. But there is a special characteristic about the surface 3 which happens to be a slant surface over there. So the slant surface, because it is inclined to the profile plane, so we are going to get again a rectangular projection which will be similar to surface 2 and surface 4, but we can observe from this isometric 3D projection that the length of the surface 3, it is much bigger than the length of the surface which happens to be corresponding to surface 2 and 4. So even though that this is a slant surface, but it will be appearing as a shorter apparent shape surface onto the profile plane while we are going to draw the side view projection. So surface 3 will be appearing as an apparent shape onto the profile plane. Then you have the top view. In the top view, so the three surfaces available, they are surface X, surface Y and surface Z. So surface X, it is the rectangular block which will be visible to us corresponding to the top surface of the lower block. So this is the lower block and this is the top surface of the lower block. So this will be appearing as a true shape onto the horizontal plane. The surface X will be true shape because it is parallel to the horizontal plane. Similarly, let us talk about surface Z first of all. So in the surface Z, again you can see it is a U-shaped surface. It's an angular surface which is having the shape which is corresponding to a U or a C, right? So this surface is again parallel to the horizontal plane, and onto the horizontal plane in the top view we are going to witness the true shape of the surface Z. Then finally we have an inclined surface, and corresponding to this inclined surface we are going to witness apparent shape projections, and this will be appearing as a rectangle in the top view. But this is the reduced size of the surface that we are going to witness in the top view. So the projection of this surface Y, which happens to be inclined to the horizontal plane as well, this will be appearing as a foreshortened view or apparent shape in the top view, right? So this way we have discussed about different surfaces, how they are going to be obtained and what type of shapes they will be available on horizontal plane, on the vertical plane and on the profile plane. Now let us start working out these projections onto the orthographic views. So in order to draw the orthographic views, first of all XY line and X1, Y1 reference lines, they have been drawn. So since we are required to draw the front view, top view and the left hand side view, front view will be drawn on this side, top view will be drawn over here, and left hand side view will be drawn on right hand side of the front view, right? So these are all the surfaces that we want to identify and appropriately locate into the orthographic projections. So in order to draw the orthographic projections, Now the transfer of surfaces also have to be done. So this is going to be our transfer line to transfer the distances from the top view onto the side view over there. Now let us start with the front view. So this is the position of the front view, where the front view will be drawn, top view will be drawn below the XY line, front view will be drawn above the XY line as per the first angle conventions, and the left hand side view will be drawn on the right hand side. Let us start with front view. What is the width of the solid? The width of the solid happens to be 75 millimeter. Height of the solid happens to be 40 millimeter. So the front view rectangle that we are going to get, that is corresponding to the front face of the solid, this will be 75 millimeter width and 40 millimeter will be the height. So please check, we have drawn 75 millimeter width and 40 millimeter is the height. So within this rectangular block, we are going to locate the front face of this particular solid, and this height 40 millimeter, it is extended along the left hand side view, because in the left hand side view also the height of the solid has to be projected. Similarly, the width of the solid, this projection line has been projected onto the top view side, because onto the top view also we are going to witness the width of the solid. So in order to draw the top view, what are the dimensions which will be required? Width equal to 75 millimeter, which has already been marked, and the height of the solid, the depth of the solid, which happens to be 45 millimeter. So depth we have marked 45, width we have marked 75 millimeter. Now this depth of the solid will be transferred using this transfer line onto the left hand side view. So in the left hand side view, we have got this dimension is equal to depth of the solid. Please check, this is the depth of the solid, and then the height of the solid is coming from the front view. So later on we are going to remove these two dimensions only for the purpose of understanding. Right now we have added these depth and height over here. Now let us start with the projections. So please check, this upper element, that is the upper block of the solid, it is starting from the rightmost end and then it is extending 40 millimeter. So the total width of the solid happens to be 75. So the upper element width is 40 millimeter, so that the width of the lower block, this will be 35 millimeter. So total is 75. 40 millimeter is the width of the upper element and 35 millimeter will be the remaining width of the lower block over there. Now we have marked this distance equal to 40 millimeter over here. Please check, this is the width of the upper element which we have marked in the top view, and we have drawn a projector line which will be moving from the top view onto the front view as well, right? So this element has been identified. Next, another thing, please check, there is the sloping portion. So this sloping portion is not starting from the rightmost end over here. This sloping portion is going to start, please check, 12 millimeter from the rightmost end. Why? Because this length has been provided to me as 28 millimeter. So the total length of the upper block happens to be 40 millimeter, and once you start from this end, I am going to measure 28 millimeter from this end. That is the end of my element number 1. So from the end of my element number 1, I am going to move 28 millimeter backwards towards the rightmost edge over there. This is going to be my rightmost edge, so that this remaining thickness will become 12 millimeter. So this dimension, even though it is not labeled, so automatically this will be 12 millimeter, because the total dimension of the upper element is 40. Then this length has been marked as 28 millimeter. So this width over here, this width will become 12 millimeter, right? Now next is that we have to mark these three elements over here. So the total, you see, the total depth of the solid, it is given to us as 45 millimeter. Out of this 45, we have got three elements: element number 1, element number 2, and element number 3, right? So corresponding to this top surface Z. So this is element 1, element 2 and element 3. And we have given the dimensions for element 3 depth over here 15 millimeter and element 2 depth over here 15. So total is 45. So the element 3 depth is 15, element 2 depth is 15. So automatically element 1 depth will be also 15. So corresponding to these three, please check, two dimensions of 15 and 15 I have marked over here, and I have drawn two horizontal lines in the top view just to indicate that the depths of the three elements in the top view is 15, 15 and 15 over here. So this depth happens to be 15. So automatically the third depth will also be equal to 15 millimeter, and these three depths, they have been transferred onto the side view also using this transfer line. Now we have got the different locations of the elements of this upper block. Now we move on to the lower block. In the lower block, what do we have? An element which is going to run through a distance of 35 millimeter from the left corner. This is my left corner. From this distance will be 35, but I need not again, you see, dimension it onto the projection over here. Reason? Because this 40 mm I have already marked, and the total distance 75 has already been marked. So automatically this distance will be available to me as 35 millimeter, and the height is equal to height of the lower block. This is equal to 15 millimeter. So I marked this distance equal to 15. So now we have been able to mark all the elements over there. Now only thing which is left is having the interrelationship between all these edges over there. That is the darkening we have to start now. Now in the front view, please check. I'll be able to get this edge. I'll be able to get this edge. I will be able to get this edge. So these three edges I'll be able to see. This edge corresponds to the lower block, whereas this edge and this edge, they belong to the upper element as well, right? So first three edges I have darkened. Then corresponding to the lower block, please check, corresponding to the surface A, I will be able to see this portion. I'll be able to see this portion, that is the upper surface of the lower block, and then I'll also be able to see the left side vertical wall corresponding to the upper element over here. So this way this surface A has been obtained in the front view. Now the next thing is, this is my surface B. So surface B has been obtained by virtue of the intersection of this inclined surface and the vertical wall which is lying on the inner side of this web, and even the vertical wall which is lying on the internal side of this web over here. So these are two webs and there are two internal surfaces. This surface is visible and this B surface on this side is not visible. So this will be surface B, but projection of surface A and B, they will be overlapping with each other, but there will be a dotted line corresponding to this inclined surface which I have to draw over here. So this is the dotted line corresponding to the inclined intermediate surface which I need to draw at this point in the front view. So this is going to be my surface A. This complete surface, please check, this complete surface is my surface A, and out of this total surface A, there is another surface which is sub part of surface A, which will be my surface B. So surface A I have marked independently. This total solid surface is going to be my surface A, and within this surface A there will be a dotted line which will correspond to the internal vertical edges corresponding to the webs over there. So this surface will be my surface B. Okay, so this surface B, it is contained by surface A. So whatever portion of surface A I have darkened, this is completely going to represent total view from the front side of this particular solid. And surface A as well as surface B, they will be true shapes because these two surfaces, surface A and surface B, they happen to be parallel to the vertical plane. Now let us start darkening the faces corresponding to the top view. So in the top view, please check, this total rectangle will be darkened. Then you have the surface X which is visible. Then you have the surface Z which will be shape of a U or a C. This is also visible, again a true shape. And then this will be your surface Y from the top view, and this will be the apparent shape. Okay, so this surface will be available over here. This is going to be my surface Y, this rectangle. So this will give me the apparent shape, rest everything will be true shape. So the outer boundary, it is visible. Then I'll draw a line over here. I'll darken this edge so that I can obtain edge X over here. So surface X is now visible to me, true shape, surface X. And then I'll draw a U over here, right? I'll draw a U or a C over here. So this will give me the top surface of this upper element. So corresponding to the upper element, this is the top surface which looks like a U or a C. So this is also true shape, section C, right? This surface C, this is true shape, surface A, this is also true shape. So surface X, it is the top surface of the lower element or a lower block. Surface X, it is the top surface of the lower block which is visible to us. So surface X and Z, they are the true shapes. Surface Y, you can see it's a smaller shape which we are able to obtain, but originally it was a longer or a lengthier surface which was visible to us, right? So the apparent shape of surface Y is visible on the horizontal plane because surface Y happens to be inclined to the horizontal plane. Now let us draw the side view. Left side view has been drawn on the right hand side. So please see, outer block will be visible to us, outer block total, and then I'll join this part so that the surface 1 will be visible. So surface 1, that is the rectangular surface, true shape has been obtained over here. Surface 1, it is this surface, true shape has been obtained in the left side view. Then surface 2 will be appearing as a rectangle over here. Again this will be true shape. This is surface 2. Then you have surface 4 which is corresponding to the vertical portion of this web number 1. So this is also visible as a true shape. But surface 3, which is same as surface Y, we have put down two numbers corresponding to the surface because of the color coding. Because in the top view the color coding was different, and in the side view the color coding is different. So that is why this is the surface 3. So surface 3, you can see it is inclined to the profile plane. So we are going to get the apparent shape of the surface over here. So this surface, it is going to be surface 3, and this is the apparent shape of the surface 3. So surface 1, surface 2 and surface 4. So this is surface 1, surface 2 and surface 4. They are the true shapes as they are appearing in the left side view, because these three surfaces, they happen to be parallel to the profile plane. Now these two dimensions, they are no longer needed. We are going to eliminate them. The coding of the surfaces, we are going to eliminate from the orthographic projections as well as the isometric projection, so that we can have a better view of the projections and we can see that how this isometric projection of a solid, that is how this 3D drawing has been converted into 2D orthographic projections. And these projections, they are front view, top view and the left hand side view. So I hope that through this discussion on the orthographic projections, you would have developed an understanding that how you can go about converting the isometric projections of a solid into three separate orthographic projections, right? So this is all for today. So we'll be continuing with few more cases on the orthographic projections of the solids in the coming lectures. Thank you. Thanks a lot.